ignore the other stuff here on the left. Some of my projects from years ago. Yeah. Anyway. Can you see it? Hello? Okay, great. So as usual, we import the different libraries here, standard stuff. But now I'll show you how to implement neural network using sklearn. You could use it to solve classification and regression problems. So we'll be using MLP classifier class in sklearn for classification and MLP regressor for regression. It's very straightforward. We won't discuss the concepts here. This is really more of application. So you just follow this code. You could get lots of data sets. Just look for that on the internet. Look for the different data sets you could get with this function in sklearn. So for this example, I'll be using the load digit. So the load digits data set is this integers between 0 and 10. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the possible targets. So this is multi-class classification. It's not binary. So yeah, just check the shape. So here's the MLP classifier. There are lots of hyperparameters that you can configure. But for this example, we'll just configure the hidden layers, the activation, and the learning rate, and also the epochs. This is epochs, or the maximum iteration. Random state that it's always there. Just set it so you could reproduce similar to the other ML models that we have used. Okay. So yeah, it is that straightforward. Similar to the other code that you have tried to run, I believe by now you've seen other examples of that. If you've been reading my notebook, the template usually is .fit and then .score. That's it, and you have your score already. For the train set, it's 0.69, and for test set, it's 0.64. Problems? Questions? It abstracts so many things in neural networks. If you want to configure other parameters, just look for the documentation, just read it. There's some things that you could configure, okay? Like this. Yeah, just read it. So many things. And then it's really complicated. Okay, but what if we scale our data? It is a good practice to scale our data. Do this all the time, as it improves the conversions. So you use the standard scaler in sklearn. There are other scaling techniques such as min-max. What else? There's this other one that I also use. I forgot. Robust scaler. But just use standard scaler. What does this do? Remember our discussion. We want our data to be zero-centered. That's going to happen if you use the standard scaler. So now that it is zero-centered and it is scaled, look at the scores with the same setup, same everything. But now we have scaled the data. You see the improvement in the scores. 0.75, 0.70. So the scores improved. If you look at the curve, the loss curve, it converged much faster than the one that is not scaled. Okay.
So, sir?
Yes.
Sorry.
Question?
Which line po is the train, and which one is the?
Oh, yeah. I deleted the legend, but the one above is the train. I Yeah, I removed this last minute. I don't know why. I was testing something, I think. But anyway, the one above is the let me check. It is the train set. The unscaled version. And the one below is the scaled version.
The green is the trained
Yeah,
and then sorry, train and then orange is scale.
correct.
All right, thank you,
Correct.
sir.
Yeah, I removed that. I don't know why I forgot. Yeah. Okay. And then for the regression, we use a data set for regression. Again, it's Boston, but you could use any other data set. So same stuff, same syntax, same everything. But look at the score. Quite low, 0.25, 0.30. But what if we scale the data again? Same old stuff. You just scale it, but the scores are much higher. See the improvement? So yeah, that's the lesson. Scale your data. Good? You guys good? I'll share the link once it's working. No questions? Okay. Yeah, I want you to do this, but yeah, the link is not working. Later. Maybe next time you do this. Oh shit. Nothing. Okay. Now we'll be using Keras. So what is Keras? It's an API designed for human beings. Well, still a bit more complicated than SQL, but yes, this is much better than using TensorFlow. So Keras is built on top of TensorFlow. If you really want to do hardcore deep learning, then use TensorFlow or PyTorch. But Keras is a higher level implementation of it. So it is better to look at, but you still have to configure so many things compared to TensorFlow. This is easier by far. And it is the most used deep learning framework on Kaggle. I'll just read the documentation for more details. It's a very big library. So you typically see the seed code. This is really important because unlike the ones in sklearn, where you just provide the seed value in your random state parameter, it is not the case in TensorFlow and Keras. It's like in every code that you will have to perform computation, you have to include it there so that you're sure that your results are reproducible. So I'll show some of those things later. But yeah, let's use another data set. Sorry, I think it's the same. Yeah, it's the same. The low digits data set. It's the same, but we'll be using the Keras approach. There are more steps. Okay. So what's happening here? We have to determine the input and output shape. So it's this one is the number of features basically, and the output shape is the shape of the output. In this case, we have encoded the data. Originally, it is, maybe I could, oopsie doopsie. No, it should not do that. I don't want to ruin this copy. Anyway, I'm just going to do it right away. So for example, I hope it's still there. Did I run this? Yeah. So this is the encoded version. So the values are from 0 to 9, right? So you want not encode it. That's what's happening here. You perform that transformation first. And then this is your modeling. So here you provide the input. And then the density, this is the hidden layer. So you have 16 nodes in your first hidden layer, and the activation is 30. Now this is the output layer already. But if you add more, then you will have lots of hidden layers. There's no limit. You can add lots of dense layers. And the activation here is softmax. That's what you use for multi-class classification. For the final layer, for the output layer. There are lots of activations, but just take note of that this is what you use for multi-class classification. You could use other things, but yeah, this is what you use. Okay, here, this one is the fitting part or the training part. So this is where you have to include the seed if you want it to be reproducible in each cell where you want to perform computation. So you run it and use a categorical cross entropy loss for multi-class classification problems. This is just a default optimizer. Use Adam. This is a really good optimizer. And the metric is accuracy at the end. So we fit it. Epochs 20, so yeah, 20 full iterations. So you can see the loss decreasing as expected. So at the end, we got, we got a very high accuracy for the low digits dataset. This is for train. Now we evaluate it using the test set. So you do extra steps in here. Because the original output of this is the probabilities for the different classes, 0 to 9. What this code does is you basically just get the class that has the highest probability. That's why it's argmax. So yeah, it's that simple. Now you end up with the original call this the original output, the one that is not yet one-hot encoded. So that's the one that we'll be using, and then we get the accuracy. So now we're comparing those two, and we get a score of 93.6 for the test set, which is high. That's good enough. Note that we use a very simple model here, just one hidden layer. If you add more hidden layers, then it's going to be higher. Make it like 3 hidden layers, or even just 2, and then increase the node size. You'll get near 100 already. Questions? No? Okay. Okay, for the regression counterpart, same old, we use the the Boston data set. And then, okay, more stuff. See, you have to implement many things when using Keras, but more if you're going to use TensorFlow. Anyway, by default, you don't have the R² metric in Keras, unfortunately, so you have to define that function. So that's what we do here. And then same old, you define the model. You instantiate it. This is our model. We have 3 hidden layers. Activation is ReLU. And then finally, it's linear. We use linear activation for regression problems in neural network. Okay. So since our output is just 1, we use a node size of 1. And the final layer, the output layer. Okay. So the model details. And then don't forget the seed. You have to set it. So, okay, we compile the model, same optimizer, Adam. The loss is mean squared error. You could use other losses if you want, but we'll just stick with mean squared error. It's the default. For the metrics, we use the R squared. And then we also use the mean absolute error. So you could output many metrics to do that. And then we train the model. Same batch size 16, fix 100. So if you look here, you can see the R squared and the mean absolute error. They're all, well, for the R squared, we need it to be higher. For the mean absolute error, we want it to be lower. So you can see it increasing for the R squared and decreasing for mean absolute error. And if you validate it, yeah, you really get a high R squared for the test set, 0.7 roughly. Okay, any questions? No questions. We'll share the notebook once my collab is fixed for this particular notebook. I don't know what's happening.